Okay. Okay. So today we have to cover more in the mapreduce. Okay. So I will be. Why the AM is not coming? Is not stopping. Okay, let us start this one. So this. Okay, so this word count flow is clear, everyone. In this word count flow, right? How many stages are there? Okay. So yesterday I discussed about the stages, right? So there is a mapper, shuffle and sort. So mapper is a one stage. and second one is the shuffle and sort, and the next stage is the reducer stage. Okay. So mapper stage is basically splitting the data into number of mapper machines. Okay. So we can say here splitting data into number of mapper machines, and each mapper machine is emitting word comma one. This is the key value pair each mapper machine is emitting. So what is the input for the mapper? The input is the mapper to the some offset comma text of line. Text of line is given input to mapper, and mapper is splitting the data into, okay. So this is an input, right? And this data is splitted, and like basically each line is given each mapper, and that is basically emitting word comma one. And shuffle and sort is basically another stage where aggregation of same key repeated at different mappers to bring at same machine and making it sorted by key. Okay. So all this like it will become sorted once if you see here, so all bus, cars, train, and plane, this all sorted. And finally reducer is, it is aggregating same key aggregating the same key and get the count for the key and return output to the output file. Return key value pair, final key value pair, key and value pair to output file. Okay. So one scenario is there, like suppose this mapper machine, this mapper has same word is repeated thousands time. Okay, suppose I say this bus is 1,000 times is there, or 10,000 times is there, or million times is the same word. So but actual mapper what is doing? The mapper is giving each word is one count, right? So what will happen, right? This bus is 10,000 times, 100,000 times, so it will be all bus comma bus, like this kind of the scenario will be there. Okay. So do you think like when the data will be shuffled, so as many number of times the key value pairs will be there, that much time it will take into the shuffle, right? If one mapper has 1,000 times the same key is there, so it will be taking more number of time to shuffle data, right? Because bus comma one, bus comma, because your mapper is emitting each word is a one count. Okay. Same scenario, if suppose train is here and that is repeated multiple times, so what will be the scenario here? Like this will be the scenario here. Okay. So if some key which is repeated in the same mapper machine, okay, that will be causing a like overhead on the network. Okay, because network bandwidth will be more. Okay, in the different mapper is there, that is fine, but if it is a same mapper, it is repeated, so we can make it, rather than bus comma one separate, we can make it bus comma 10,000, right? So if I apply, if I apply the same logic which I'm doing in the reducer, if I apply same logic of reducer at mapper side, that is called combiner. Okay. So if this kind of logic, which same thing is mapper is reducer is doing, if the same logic, if I apply in the same logic in the one mapper, like on different mappers. So that is called combiner. So we can say what is the difference between the combiner and reducer. Okay, so reducer and combiner both having the same code. Both have same code. Okay, so whatever code you have written, both have same code. So what code we have written in combiner, in reducer, okay, same class, same Java class, I can use as combiner. I don't need to write a separate code. Okay, but difference is here in the combiner and reducer, like combiner is applying in the same mapper machine only. Combiner is applying logic at same machine. Okay, so all different mapper machine, different mapper machine using same logic of reducer. Okay, but reducer is combining keys. Okay, aggregating the keys from different mappers, same key, different mappers, same key. Okay, so you can say here, like if bus comma 1 is here, like, or bus comma 1 is here, that aggregation is done by the reducer. So both are using the same code, but combiner is mapper side first of all, and reducer is like combiner is a mapper side and reducer is the reducer side is there. Okay, and the combiner is doing the aggregation from the same machine, and reducer is doing the aggregation from the different mapper machines output. Okay, so that is so we can say combiner is basically improving the performance of MapReduce job. Okay, so you can say like your performance wherever the data is repeated more number of times, so there you can improve the performance using the combiner. So in your job class, you know your driver class, right? In the driver class, you know, we have created some job object, right? And job dot set combiner class one method, there you give the same reducer class only, reducer dot class. So job dot set reducer class also you have to do reducer class. Okay, set combiner class method you will pass the reducer class, and set reducer class method also you pass the reducer class. So both will be using the same reducer class, but combiner will act at the side of mapper and reducer will be reducer side. And combiner will be act at the mapper side because it will improve the performance where the data is repeated in the same mapper machine. Okay, so this is a concept of combiner. Another concept is there, partitioner. Okay, so one scenario is there. Suppose I'm doing the word count. Okay, so final word count is coming like this. Suppose hello comma 20. Okay, x and I comma 4. Okay, like this you have the file and some word is there xyg comma 7. Okay, so if I say, if you are creating a one single output file, this is a one single output file. Okay, but suppose if the file output is very large, if the output is very large, if output is very large and you want to sort, you want to write output such a way, like if particular word count you want to search, you can find the word in a file. Okay, so I will distribute the output into number of output file. The one output file I will divide into the multiple output file, and some logic I will write in the partitioner class. I will write a logic write logic to distribute my output into number of output file, and distribute the output based on distribute output based on some logic. Okay, so what logic could be possible here? Like suppose I say the word starting the letter A, okay, they should go one file. Okay, word starting B letter should go second file. Okay, like I say the G letter starting word should go to the 26th file. So here I have to write a logic, so automatically the word count will be distributed into number of output file. It could be a less or more depending on the logic, right? Suppose I say I want to find out only A letter word. So I will keep it in one file, and remaining letters word I can redirect to another file, only one file. So total 2 files I can create. So here, this is my requirement. Based on the requirement, I can decide how many number of output file I want to create. So here, the reducer is in our control. Reducer is in our control. We can decide how many number of output file we want. So those number of reducer file will be created. Reducer files will be created in file will be created in mapreduce job. Okay, so this partitioner will be a separate Java class. The name will be some my partitioner class, and it will be extending some partitioner API class, which is taking some parameter, and then here we have some get partition function. In this get partition function, we write a logic here. So mapper side. So first of all, your input is taken by your mapper. Okay, suppose you applied the combiner, then combiner will come in picture. Okay, after combiner, your partitioner will come in picture. Okay, and then shuffle and sort will come. And then reducer will come. Okay, so this will be the flow and final output data. So this partitioner will decide how many number of output file will be there. If this partitioner is a default partitioner, is a hash partitioner, so only one file will be there. So default partitioner is hash partitioner, which is using hashing technique to distribute the output. Okay, hashing technique is nothing but hash value it will calculate, and all data will go in one file only. Hash partitioner means only one output file. Okay, because I have not written my custom partitioner logic. I didn't write. So if I write my custom partitioner, class, then it will generate number of output file. So this number of output file, like there is one property is there, job dot set num reducer task. So here I have to pass the number, how many output file I want to create. So in driver class, I have to set this property. So two things I need for partitioner. So one thing I need it, I have to set it this property job dot set num reduce task, and I have to set in the job set partitioner class. The job dot set partitioner class. So here I will give my partitioner class dot class. So I will write it like this. So how many concepts we've seen so far? First, we have seen what is MapReduce architecture. Okay, so MapReduce architecture having the map and reduce two functions, map and reduce, and shuffle and sort. Okay, so these are the basic MapReduce program. Okay, next is if my data is repeated more number of times in the same mapper, so that is a bottleneck for my application. So I'm using a combiner. Combiner combiner is another concept in MapReduce for providing a mini reducer. It is a mini reducer, right? I told you whatever your reducer file is there, reducer class is there, that is provided as a combiner. So that is the reason combiner is called mini reducer. Okay, that is another name for combiner. Next concept is in partitioner in MapReduce. So map partitioner is basically distributing your output data into number of output file. If I need to make it read my output easily, right? This is for reading purpose, right? Like basically, if I want to make it my output is having a more clarity, right? Like basically, I can easily use my output, so I can use the partitioner. Okay. Okay, so if VM is come, okay. Yeah, I check it. My intelligence there. When we go to win, here we have to start dot slash idea dot sh. So it will start my VM, my IntelliJ. So here start my Java project dot count. Okay, so Maven type project we have to create. Java type can use to that one. Mapreduce count. So this is a default workspace where this project is creating. There is an idea project folder is creating in the our home folder, and there this project will create. Okay, so JDK is taking a 1.8 and it is nothing. Okay, archetype I have to select Maven archetype quick start for the any core Java project like core Java application we can create using this Maven archetype quick start. Okay. So after that I will do create. Okay, so this is basic Maven project is going to create. So it is taking time. So it is creating a like SRC folder will come, source folder. So this source folder, I have to write the Java classes. So first thing is once this SRC comes, okay, so I have to add the dependency in my pom.xml. Okay, so in this pom.xml, I need this is the Maven project. Okay, so what is Maven? Maven is a build tool which is building this project, which is compiling and creating a jar of this project. So everything is done by this pom.xml. So pom.xml is suppose I'm using some library API of the MapReduce. So those library it will download from the Google using this build.xml, this pom.xml file. So here is a tag, here is a project name. If you see whatever project I created, so it is coming a group ID, artifact ID. Artifact ID is nothing but your project name. So that will come as a project name, and group ID is whatever your package is created, right? Your base package. So package is nothing but a folder where you created your Java class. Okay. So the base package is org example package. Okay, so this package is called the group ID, and version is I want to create some project with a specific version. So that one is version is there 1.0 snapshot or 1.0 release. So this is for tagging it, right? Like my project is with which version, and packaging is of this project is jar type. Like when I'm just creating a jar, and jar is having the classes, and classes is nothing but whatever our source code is there, Java classes are there, the classes will be created and that will be packaging as a jar package. Okay, I will show that how to create a jar. That is a simple Java language concept, like how to create a project and how to create a jar, and this jar we will use it for running our MapReduce program in the cluster. Okay, so first I'm adding some dependency of MapReduce program. Okay, So I need a mapreduce jar dependency. So mapreduce what mapreduce. So I'm finding which jar I needed. So mapreduce client jar, mapreduce 3 jars are there. So like this is the form.xml and here very old one. So this is my code, Hadoop word count. Okay. So this project, I can import it, this code in the IntelliJ. Okay. So this is the project. I created in the new window so that we can add the files in our project. Okay. So this is already existing project. Okay. So I have done the git clone and I took the code from the Google, and this is the already pre-built project, right? Already have the all these classes which we needed. So just we have to compile it. Okay. First we run this and then we will add the files in our code. Okay. So first we look at the form.xml. So in form.xml, it is using Hadoop 2.x version. So this is the dependency jar, like dependency API. This is a group ID, artifact ID. So this is the dependency, okay, which is used in this 3 classes. So one class is a mapper class. Okay, so we have to set up a JDK here. So JDK is my JDK 1.8. So I'm adding a 1.8 here. Okay. So first of all, it should not give any compilation error. So I need to build this project. Okay. So this is my main class, the driver class. Okay. So I'm running the project here. Okay. Still it is downloading the dependency. So if you look at here in the down, there is the downloading the dependency. Okay. So this is the project. I took it from the Google and then downloaded. Okay. but we can create the same files in our project, and then we add this pom.xml dependency in our project, and then we can run the same project like this. Okay, so first we are running the pre-existing code, right? Okay, so that we can come to know how this class is the code, how code is running. Okay, so we can write this code in our files also, like we have to write like a one word count job. This is a driver class. So here three classes are separate classes are created. One is a driver class, one is a mapper class, and one is a reducer class. So if I look at the reducer class, it has the logic of aggregating the values. If you see here, like my total is there, this is my total result number, and I'm doing result number equal to result number plus value dot get. So whatever value I'm getting here for each key number of times, like this value is repeated, right? 1, 1, 1. So for each key, it is number of time repeated value. I'm aggregating all the values, and final result number, that is my sum, that I'm writing into the my context. The context I told it is a common variable between the mapper and reducer. So if you look at the mapper code, so mapper code is what is doing. So some other functions also there in the mapper, like setup function is there, but we are having a map function. This is a map function. So setup function, like we can use some code, like some initialization things I want to do. I will tell later what is the use of this setup function, but our main logic in this mapper function. So mapper function is taking as a key as a object, and text is a value, and text input the value, and then context. So here I'm splitting the word by space. Okay, each word, and then giving the each word is a one count here. Okay, I'm writing in the context, each word is a one count, and then here is actually counter concept is used. So I will tell later about this, like what is this counter thing. So it is counter is basically used for the debugging and tracing, right? Suppose some error comes, so you can increment your counter. Suppose you created a one counter enum, like particular input word, right? You are defining, so you will be making it counter one. So here is mapper function logic is to each word you are giving one value. Here it is this one, context dot write, and reducer logic is taking the value from the context, and you are getting the value, and then sum all the values for the same key. Okay, but if I want to apply the combiner, so just I need to add here in the job. So job here already mapper class is there. Combiner you want to use, just use combiner and give the same reducer class. Can you check? Here both the classes are same class. Combiner class is same and reducer class is same. Okay. Okay, now I am going to run my program. Let's see. So this mapreduce program I'm running in the editor itself. Okay. This is a without actual cluster. Okay. So this is without actual cluster. I'm using the mapreduce. So I have to pass some input parameter and output parameter. Okay. So I have to configure the job, edit configuration. So I'm creating this job. So here, this is my main class, and I have to provide some input parameter. I want to say, where is my output file? Okay. So I say my output file is here. I'm taking some output input file. So in my home folder, suppose this file doesn't have data, test.txt. Okay, this file has data. So test.txt, I'm taking input file. So that is my input, test.txt. And I want to create an output in some directory. So directory should be always a new, because Hadoop is creating always a new directory. If you have given existing output directory, so it will give you the error. So either you should delete a directory or you should change the directory manually. So I'm giving some directory here, output 1. So my output should come inside this directory. So I have to set it this configuration, because these two parameters are taken here as a parameter. If you see args, So ARGS will receive your parameter length, and it will use this 0 and 1 parameter here, for one for input and one for output. Okay. I think here is two more parameter is there, but we don't use this logic for this logic. We should not use. This is for like automatically we can delete our file. So only two parameters we will be taking, ARGS 0 and ARGS 1. So ARGS 0 parameter will be used as a your input file, and ARGS and this output parameter is a like your directory. Okay, so now I run this word count job. Okay, index out of 1. I directly give the parameter ARGS of 0. So 0. Bracket. Bracket will come. So now done very quickly. Here is output 1. What is the folder name I given? Here in the configuration, edit configuration, I given output 1. Yeah, it's done, right? See, this is the one. This is output is coming. Okay. So, okay. So if I delete this output 1, okay, in this test.txt, I repeat this. Okay, so now I'm saving this file. I saved the file, and now, and I have deleted output directory, because if I don't delete it, it will give me the error. I will show that. So how fast this program is executed, it's done, right? Because combiner, suppose if I if I comment the combiner, okay, first we see the output 1. Okay, can you see this is all same, 8208 8208. Okay, so if I don't delete this one, I run my program again, what error will come? Output directory file is already exist, because I didn't delete it. So either I should write some logic which can delete automatically by my program, okay, or I should delete it manually, or I should give it new one. So Now if I right now combiner is working because it is making it more faster. Okay, so I just comment this combiner. Okay, I should not use combiner. And now I delete this output directory. Okay, now I run my program. So still its output is coming faster because it's still data is not very huge, right? Like where data is, but output will remain same because combiner is just making it more like a faster because it's the same key is repeated more number of times. So here, delete this in this text file. So okay, I did this change. Okay. Now I run my mapreduce program. Done. So if I check output, so here you can see whatever I give in extra hello one, file one, is one. So one time is coming, right? So one extra line is added. So this is like your MapReduce word count. Okay. So I show you the same thing how to do on the cluster. Okay. So first I have to start my cluster. So I start my start-all.sh. Okay. So this is just testing purpose we do in IntelliJ. IntelliJ we use the test the logic. And this program is running because of the jar. So whatever jar is there, if you see the target, okay, I can create a Maven packaging I can do. I need to do some jar I need to create. So how to create a jar of this one? So I have to create a Maven type of application. So here is this is a simple application, simple main application I'm running it. But when I want to run on the cluster, so I have to create a jar. So for that, I have to create a Maven type application, Maven. And here I have to give the command clean, compile and package or clean package. Okay. So clean is basically whatever existing jar will be there, that will be clean. Okay. And some new dependencies need to be downloaded, it will download. And package will create a jar. So it is taking the directory, which directory it has to do clean package. So just I created a one Maven type, our job, right? Maven type. So this, when I run this, so it will create a jar in my target folder. So target folder, I will create a jar, and that jar I will use to run a job in MapReduce cluster. Okay. So when I go here, so my jar is created. So you seen that in the beginning, I told about in the pom.xml. So whatever the group ID, artifact ID, and snapshot, so it is using this artifact ID and version to create a jar naming convention is from this artifact ID and version. Okay. So this jar I will copy in some directory. I will copy it like where I want to run my MapReduce jar. So here I paste it, and here I. So first of all, my jar is here. Okay. So I have to write some data into my Hadoop file system. Okay. So I'm creating a Hadoop directory, Hadoop fs minus mkdir, and some map word count directory I'm creating. Okay. So whatever input and output both will be in Hadoop. When I'm submitting the job, when I'm running a MapReduce job on Hadoop cluster, so I should have my input directory and output input file and output directory both should be on Hadoop cluster. Okay. So here I'm just creating some text file. Suppose this is my file. Now this file I'm copying it to Hadoop. So Hadoop fs minus put hello.txt, and I'm sending to mapreduce directory. Okay, so this is my input file. Okay, so now my jar is here. Now I will use Hadoop jar command. How to run in the cluster? Hadoop jar. I have to give the jar name. The jar name is jar is word count snapshot jar. Then I have to give the class. So class, which class we is the driver class? So that class with package will come. So my word count dot job, right? This one, this is my main class. And what is the package for this? So there is no package is there. So I'm directly running the class. So this class, my driver class. And after that, I have to give for this class is a Java class is a driver class. And after that, input and output path. So what is my input path? mapreduce hello.txt. This is my input path. And what is my output? mapreduce some output directory I have to create, that should be new directory. So this output one is not there. I have not created any output one inside this. So this output one will be created. Same thing, whatever we discussed in the word count program in IntelliJ. So same thing is here. When I run this job, so this job is running on the cluster. So here you can see the logs also creating, right? It is telling about how this is a particular job ID, right? So how many mapper and reducer is there? So you can see, so in this map is 0%, reduce is 0%, map is done 100% and reduce is done 100%, and your job is completed. Once your job is completed, it will be telling you how many input record you read and how many output record you generated. Input record means how many lines of input you read in your mapper and how many number of record it generated. So you can get it here, output record. So now we have to check our output file. How to check? Hadoop fs minus cat command, and I gave my mapreduce. What is my directory name? Mapreduce. Okay, mapreduce, and folder name is output one. So some naming convention it takes. Map R, part R, 000. Okay, so 5 zeros. Can you see this is the output? Okay, HELL 1 time, hello is 2 time, and test 2 time. So this job is running my actual cluster, right? Whatever my Hadoop cluster. Okay. So if I have only one node, but suppose the same MapReduce program you're running on your multi-node cluster, right? Where you have 10 node, 5 nodes. So your data like a word count will be faster, right? Because if it is more number of nodes. Okay. So this is the way like how to run a simple MapReduce word count. Okay. And this project, right? Right now combiner I commented. Okay. So when I want to use combiner, just I need to, in the driver class here, I have to enable the combiner. So combiner class is there, but it is not enabled. When it will enabled, when I use set combiner class. Okay. Okay. Any question, doubt in this? So we can use like a same partitioner, like I found it in Google, like some word count program is there. So they are telling about the same procedure, right? Hadoop fs, you can create some directory, then put command or copy local command, some input.txt. They have given input file also or not. Okay. So you can write some output file, and then you can use Hadoop jar command, and then you keep the input and output directory path. And then you will see your output, you can see in your Hadoop directory. Okay. So I will give this word count program code. Okay. Okay. So you can create a new project. Suppose your project is, this project is here, right? So how to do first? So you copy first pom.xml. So this dependency you needed in your pom.xml. So this dependency, this particular dependency. So you copy this and write it in your here in this. another dependency. So this will bring your whatever the jar you are importing, right? So it will not give the error, right? So your code will compile. Okay. And next thing is you have 3 classes out there. So you have 3 classes. So you are creating first class, second, third, three classes. So these classes you can create manually one by one, or you can copy paste and you can see the output. The same thing you have to configure here. So here your package is there. So you are so here in this, so when I will run my mapreduce program, now here I create a one jar here. So how to create a jar? So here I have to create a maven configuration. Okay, maven configuration. Here I have to give the command clean package, and then I have to give the okay, and then I have to run it, and then it will create a jar. And this jar I can run. And second way is like I can directly run this. Right now error is coming because it has to import the library. So here is a maven, you go and reload project. So it will be importing the, now no error is coming because already this pom.xml dependency is downloaded from the Google. Okay, it came into your local folder because when I run this project. So that is the reason first time it takes time to download dependency from the Google, but already the same dependency you are using in another project, it will not take much time because it is present in your local. Now I can run the word count program. So for locally you want to run word count program, so you have to create a simple application. You have to create a simple application here. In this simple application, mapreduce word count, and here you have to give your main class. Your main class name is word count job. This is your driver class, main class. Okay, and here you have to give the 2 parameters. So /home/ my username / here is test.txt file is there. Input path you can give anything, whatever path you have the file / and new directory I'm creating here. I need to create put 2. Okay, and then to apply. Okay, and then I can run my. So this is for testing purpose. You can run in IntelliJ. So once your program is completed, you can see your output in the output 2 directory. So output 1, output 2 is created just now, and same output is there. Okay, I'll share the programs. Anyone has question, doubt? It is just for nobody's asking to write this MapReduce code, but understanding point of view. Okay, tomorrow I will tell partitioner and join. Okay, so tomorrow I will complete this MapReduce. So join, and I will tell about partitioner logic, how to add your partitioner logic in the same this word count. Okay. Okay. Yeah. Thanks everyone. Thank you.
Yeah, thank you.
Thank you. Hey, Aaron, are we practicing the pitch?
Practicing what?
The pitch, or should I send you my video? Because I just finished
Okay,
preparing it.
okay.
Now I have to read. I
Mm,
have to look and read.
okay.
Or can we take like 4 minutes to do?
I'll connect to you. I'll connect to you. Okay.
Okay.